Okay, good morning and welcome to Math 8 and our second lesson for Chapter 3. If you are following along in the note packet with us today, we are on the section, second page, that says 3-2, Connect Representations of Functions. And we have to start with some vocabulary today, so I'm just going to leave this on screen for a second as I talk, but feel free to pause the video and also pause the video and get the whole definition down if I go too fast. Okay, so the first word is linear function that we need to have a definition for. Notice in this word there's the word line. And that's on purpose because linear function means that it will graph a straight line and has a constant rate or slope. Where nonlinear means does not graph a straight line or have a constant rate or slope. In this lesson, we're going to talk about rate of change again, which is the same as slope. So a reminder for that is that means we get y2 minus y1 over x2 minus x1. And in the equation, that would be the number next to the x. And then we're going to talk about initial value, which we know better as the y-intercept. And that's the value of y when x is 0. And in the equation, that's the one that is not next to the x. And just a reminder after yesterday's lesson, what the vertical line test is. And that is that any vertical line may not pass through a graph more than once to be a function. Okay, again, pause the video here if you need time to write it down. But for essence of time in the video, we're going to move on to the first example. So if you turn the page of your note packet, the first example on there looks like this. But what you do not have on yours is this graph and table that I have. So I know if you are following our packet, then you have a different graph. Go ahead and cross that out. And again, you might have to pause the video to create this new graph. And you won't have graph paper probably, but at least draw the line. We want it to go to 10 here, and we want it to go to 10,000 here on the x and y axis. Okay, so, and once you have your graph drawn and your table drawn, let's talk about the question. So the question today that we're starting with is a 10,000 gallon swimming pool needs to be emptied. Exactly 2,000 gallons have already been pumped out of the pool. If the pump is pulling water out of the pool at 720 gallons per hour, write an equation and create a graph to determine how long it will take to pump all of the water out of the pool. Okay, so what we need to start with here is writing an equation. So we need to be able to determine what numbers we need for our equation. So we've got 10,000 as an option, we've got 2,000 as an option, and 720 as an option. So let's talk about this. We want to know the answer we're seeking is when 10,000 gallons will be all the way out of the pool. So that's going to end up being what we're looking for. So in the equation, what we're trying to use is the 2,000 gallons that's already been pumped out and the 720 gallons per hour. So remember, our equation, we really want it to be y equals, oh, let me change color here. So y equals, well, 2,000 gallons have already been pumped out and 720 gallons are being pumped out per hour. So I'm going to start with the 2,000 that's already been pumped out. Then I'm going to add the 720 gallons per hour. Now one of these needs an X on it for this to work. So the word per on something indicates that this one is our rate. So this is the one that needs the X on it, or our slope or our rate. So now what we want to do is make a table so that we can graph the values here, all right? And so some of you might want a calculator to be able to do this. And if you don't have one, use your phone or your Chromebook. But I'm going to show you kind of a couple of spots. So what we want to do is we want to use some simple numbers to see when it's going to hit 10,000. So let's start with, we know at 0 we're going to start with 0, and then we're going to go 1 and 2, and we're going to see if we have to go any further, okay? So what we do here is in the middle, we say y equals, and we're replacing our x with 0 for the first one. 2,000 plus 720 times 0 for x. Well, 720 times 0 is 0, plus 2,000 gives us 2,000. And that means our first ordered pair is 0, 2,000. So if we put that on the graph, 0, 2,000 is right here. And so we're going to make a dot there. Okay, let's go again. Y equals 2,000 plus 720 times 1 hour. Okay, well 720 times 1 is 720 plus 2,000 gives us 2,720. Okay, so that's our next ordered pair. Is going to be 1, that's the first one, comma, 2,720. Okay, and so to graph that, it's a little bit different because here's 1, but 2,720 is not on there, so we have to estimate. So if it goes 2,000 to 4,000, this is 3,000, and we're not quite there yet, so we're going to put a dot here. All right, let's go again. Y equals 2,000 plus 720 times 2. Okay, so this is where some of you might need a calculator, but 720 times 2 is going to give us 1,440, all right? And then we're going to add that to 2,000, right? So 3,440 is going to be what we get. Okay, so our third ordered pair is 2, 3,440. Again, that's not on here, so at 2, we have to estimate. So here's 3,000, there's 4,000, right? And so halfway through would be 3,500, and so we got to go just under that. And notice that this is going in a straight line. It should be. This is called linear. Okay, and we talked about that in the vocab. This is linear because it's 720 gallons per hour and it's not changing. That makes this a constant rate going up each time. And so once you know that that's the pattern, you know that you can continue to add 720 each time. So the third hour, if I add 720 to the 3,440, I don't have to do all of the work in the middle to know that my next one is going to be 4,160, okay? And so 4,160, and on my graph it should be making this nice straight line. All right, so the question is, how long will it take to empty the 10,000 gallons? So we need to get all the way up here. So one way you can use the graph to do that is by drawing a line through your graph like this. And you can now follow that up to 10,000. So 10,000 going across lands about right here. And now we use the graph to estimate, oh, that would be about, it would take about 10 hours to empty the pool. Okay, and so that's one way that we can use a graph and use a linear function to estimate how many hours it would take to empty that pool, or use a linear function. Okay, so we're going to practice more of that in your textbook today, but let's move on, okay? So the next question is going back to using the vertical line test. So, vertical line test, let's recall, means that to decide whether something is a function or not a function, we drop vertical lines and see if any of them hit more than one spot. For example, this first one, if I drop a vertical line here, it only hits my graph in one spot. If I drop a vertical line here, again, only one spot. If I look across, anywhere I drop a vertical line, it's only going to hit this graph in one spot. This means it passes the vertical line test. So this is a function. It passes the vertical line test. And we're going to abbreviate that, VLT. Okay? Now the next one, if you drop a vertical line on this graph, let's drop one right here, it hits the graph in 2 spots on our very first line. So this one, since it hits twice, this fails the vertical line test. So this is not a function. Anytime it hits the graph in more than one spot on a vertical line, it fails the vertical line test, making it not a function. Okay, so look at the last one. What do you think? If I drop vertical lines on this, is there anywhere that there's going to be a place that it would hit more than one spot? You answer that one on your own. Okay, last example today. This is another one where we're going to have to graph it and then show it on your graph here. Make a table, make a graph. Now this one made a table for us again. And so what you want to do is fill out the table and then make the graph just like we did in example 1. I want to point out the difference is that this has a squared in it. And so on your calculator, to get a squared sign, you either multiply by itself or you use the little caret key that looks like this. So I'm only going to get you started on this one for the sake of the video and let you finish it. So the question is this. If the area of a square is determined by the formula A equals S squared, where S is the side length, make a table and a graph to show whether the relationship between the side length and the area is a function. Okay, so this table right here is set up a little different than we normally do. So we're going to put our work out to the side. And remember, our work is the equation. So the equation we're using is A equal S squared. Okay, so in our first one, what we would do, and I'm just going to extend the table out here for each one. You would say, oh, okay, S is 0, so A equals 0 squared. So on your calculator, you can do 0 caret 2, or 0 times 0, and we get our first answer of 0. So the first ordered pair is 0, comma 0. Okay, let's do another one. The next one is 1, so we're going to do A equal 1 squared. Okay, well, 1 squared, 1 caret 2, or 1 times 1 is 1. So my next ordered pair is 1, comma 1. Okay, and so now you're looking at it, okay, this graph is not labeled at all this time. So what we want to do is make sure that we label it. This is going to be our side length here, and here is going to be A, our area. So we label that S and A. And so what you want to do is number it. This is 0, 1, 2, 3, 4, 5, 6, 7, right? And this one is going to go 0 this way, 1, 2, 3, 4, 5, 6, 7. You might have to extend this graph out a little bit to make it work, but 0, 0 is right here then. 1, 1 is right here. Now you do the answers for 2 and 3, put them on the graph and decide whether this is a function or not a function. If you have any questions, please feel free to email me and I will get back to you as soon as I can. Have a great day, everybody.